Dear students, good evening. I am Ramdas. I welcome you to my channel Maths from Basics for You. So today is my class number 21. So in the previous class, I remember I have taught you derivatives of composite functions or chain rule, or is also called as function of a function rule. So in the previous class, I have taught you part 1 of composite functions, and I am going to continue with part 2 because I want to do variety of problems so that you are sound in mathematics, because this here you will be learning more of steps, how to solve these problems using steps, and it will make you more fluent with the problems. So let's start without any delay. And before I start, remember my funda, learn maths from basics. I am there to teach you maths right from basics. So dear students, so before I start, once again I remind you, please like, share and subscribe to my channel. And beyond this, I cannot force you, compel you to do so. So let's start. So dear students, first a problem is given to you. Before starting, I want you to think for a while, 1 minute, think how to approach and how to tackle the problem, because you have to recognize the problem, and once you recognize the problem, it will be easy for you to do the problem. Here you don't have any clue how to do it, but you have a hint, because the answer is hidden within the problem. So if you see here, if y equals under the root x plus 1 plus under the root x minus 1, prove that under the root x square minus 1 into dy by dx equals to half y. So here dy by dx indicates that you have to differentiate this, because there is no other way. Only way is you have to differentiate this. If you differentiate this, try to follow the steps and you will reach, because he has given you y. What is y? This is y. So you will do it automatically. Let us see how to solve this problem. So what I will do is, straight away I will differentiate this. So what happens here? Dy by dx equals to what? D by dx of, I will take this, under the root x plus 1 plus under the root x minus 1. Okay. So what happens here? So if you differentiate this, this becomes half into root of x plus 1. You have plus, put plus, again half into d by dx of x minus 1. Now here you have to differentiate the inner function, but what has happened, the moment you differentiate d by dx of x is 1, so here you get 1, but no use, let us ignore it. In the event if you had x square here, you should have even differentiated x square also. D by dx of x square would have been 2x, but since you have x, straight away you can write 1 and ignore it. So now you got this. So what I will do, I will try to take common. What is common in this? Half. I will take half common. Then what happens here? 1 by under the root x plus 1 plus 1 by x minus 1. I take this out. Okay, sorry. So I have taken a half outside, and we are left with what? 1 by under the root x plus 1 plus 1 by under the root x minus 1. So what you do, next step is take LCM. Once you take LCM, you will reach here. So I will show you how to do this. So I will take what? LCM. What is LCM out of this? You have to take both the values, that is under the root x plus 1 into x minus 1, right? This is our LCM. So now you divide this, x plus 1 is there, you are not having x minus 1, so this becomes what? X minus 1. You have a plus sign, put a plus sign, and becomes x plus 1. So you have half here, so take that half half, and on the left hand side dy by dx equals to this, right? So dy by dx equals to half into this becomes what? I will interchange this. I will write it x plus 1 plus x minus 1. Can I write like this? A plus b or b plus a. So I will interchange the values because we have a plus sign. If we had a minus, I couldn't have interchanged this. Since we have under the root x plus 1 plus x minus 1, so I have interchanged this. First I have taken this value here and I have sent this value here. And if you multiply this, what happens? This into x, under the root x plus 1 into under the root x minus 1 becomes, that is a plus b into a minus b type it is. So this becomes what? Under the root x square minus 1. So this reduces to x square minus 1. I cross multiply this. So what I will do? I will multiply because here x square minus 1 into dy by dx. So we have dy by dx. The moment I multiply this, we get this, and half we have here, half. And what is this? This is nothing but our y. We got the answer. So almost, so this becomes, that implies dy by dx into, I cross multiply, I write this, cross multiply, this becomes under x square minus 1 equals to, I will write here, equals to half into root of x plus 1 plus under the root x minus 1. Right? What is x plus 1 under the root and plus x under the root x minus 1? It is nothing but your y. So this is nothing but half into y. Since y equals to x plus 1 plus under the root x minus 1. Therefore, what do you want? X square into this. We already got this. So I will interchange this. A into b or b into a, both are same. So what happens? I will write that in that form only. That is x square minus 1 into dy by dx equals to, this is the answer. Therefore, x square minus under the root x square minus 1 dy by dx equals to half y, since y equals to this value. Done? So we have solved this problem. This is very simple problem. Only here the trick is you have to recognize or try to find out what is the logic behind a problem, given problem. Once you arrive at that, it will be easy for you to simplify, because everything is nothing but steps. You have to follow the steps here. Nothing impossible here. Everything is possible provided you use your head. Okay, students, please copy this. I'll go for next problem. So dear students, we have another problem. If y equals to under the root x plus 1 by under the root 1 by x, that is under the root 1 by x, prove that 2 into x into dy by dx equals to under the root x minus 1 by under the root x. So here once again I have told you, very simple problem. Only thing you have to catch the clue how to solve this problem. Once you recognize that point, easily can solve this problem. See here what he wants. He wants you to find dy by dx. So with this you have to find dy by dx. Okay, fine. Then what he wants? He wants you to multiply that with x. Let us see. Because once we have this root x, it means it gives half root x. That idea you should have in your mind. We divide this 1 by x, so it is half root x. So with that logic you can proceed. So we'll differentiate this. So what we'll do? Differentiate, that is dy by dx equals to d by dx of under the root x plus 1 by under the root x. So what is the easiest way to solve this? What I will do is I reduce this to, what is root x? X to the power of, can I write like this? Okay. So this is nothing but d by dx of x to the power of, I will write half, plus under the root x to the power of half. Done? Okay, now this is equals to d by dx of x to the power of half plus x to the power of minus half. So I have taken to the numerator. So once you take the numerator, it becomes x to the power of minus half. Now it is handed for sum rule, differentiate this. Now it is very easy to differentiate this. So what we will do? So this is equals to what? 1 by tilde x to the power of half minus 1 plus, so this is minus half, we have minus half, I'll write this, plus as it is minus, we can we could have avoided one step, straight away I could have taken minus. I don't want you to get confused, that's why I have taken this within the bracket into x to the power of minus half minus 1. So x to the power of minus half, that is my n minus 1. So this is value of n is minus half it is. So this minus half minus 1. I will take a line here. So we solve this. What happens to this? Dy by left hand side dy by dx. So this becomes half into x to the power of, we get half minus 1 is minus half. So minus into plus minus x to the power of minus half minus 1 is minus 3 by 2 to the power of minus 3 by 2. Next, see, you have already got a hint. What? This is the moment you want to, if you cross multiply, you get 2. Now you want x, multiply both sides by x. Isn't it? You got answer. Dy by dx you have already got. What he wants? See, in every problem, the answer is hidden. Here, if you are smart enough, you can easily find out. So what you do is, he wants dy by dx, already you got it. You have to, this 2 will come here. So multiply this with x on both sides. Over. Problem is over. So what I will do is, I will take this on the right hand side, that becomes 2 into dy by dx equals to what? X to the power of minus half minus x to the power of minus 3 by 2. Done? So what he wants? 2 into x into dy by dx. I have to multiply this x. If I multiply x on this side, I should multiply there also. Otherwise, you can't. So multiply both sides by multiplying by x on both sides. We get, what happens here? So LH side is 2 into x dy by dx. So have we got our left hand side? Yes. Now what happens here? This is equals to x into x to the power of minus half minus x to the power of minus 3 by 2. Done. So I rub this. So that is 2x dy by dx equals to, if you multiply this, what happens? Bases are okay, I'll take inside. So this becomes x into x to the power of minus half minus x into x to the power of minus 3 by 2. Done? Because x has to be multiplied for both the terms. So bases are same, add the indices. This becomes x to the power of 1 minus half. Where 1, this is the power of 1, this is power 1. So 1 minus half minus x to the power of 1 minus 3 by 2. That is minus, that is x to the power minus 3 by 2 is minus half. How we got this? I will show you. That is 1 minus 3 by 2. LCM is 2. This is 2 minus 1 goes, that is 3. That becomes minus half. So minus half. Done. So this becomes what? This becomes, on the left hand side we have 2x dy by dx equals to, this is x to the power of half, 1 minus half is half minus, so what I will do is I will send this to denominator. So this becomes x to the power of plus half. Okay, what is x to the power of half? Is nothing but root x minus 1 by root x. We got it. So rub here. So that is two x into dy by dx equals to what? This is x to the power of half is nothing but root x minus 1 by root x, since x to the power of half equals to root x. Okay. Therefore 2 into, on the left hand side we have 2 into x dy by dx equals to root x minus 1 by root x. So this is our answer. Do you think the problem is very easy, dear students? See, follow the question, you will get answer. You got dy by dx, you have to multiply by 2x. Got it. Done? Okay, we'll go for next problem. So dear students, we have one more problem here. That is y equals to under root a square minus x square. Show that y into dy by dx plus x equals to 0. Very, very simple problem. Just multiply this, that differentiate this, we get the answer. So I'll show you how to do this. Now dy by dx equals to d by dx of under the root a square minus x square. Done. So we differentiate this, anything under the root it will be half root, and later on we differentiate the inner portion. It's a composite function. So this becomes what? Half into under the root a square minus x square. So d by into d by dx of minus x square. So dy dx of minus x square. So what happens is, this is 1 by 2 into root of a square minus x square into minus 2x. If you differentiate x square, you get 2x. So minus sign is a minus sign. So what happens to this? Dy by, on the left hand side, dy by dx equals to half. So I take this into, that is root of a square minus x square into minus 2x. This 2 cancels. So that is equals to minus x by under the root a square minus x square. So this is our dy by dx. In these problems, keep writing this dy by dx because we need this. So don't forget to add this later on. See what he wants? He wants y into dy by dx. So send this here. So by cross multiplying. So that is nothing but he wants in the what side? Y. So we have a square minus x square into dy by dx equals to minus x. Got answer. If you bring this minus x towards left hand side, you get plus x, and the right hand side has 0. The answer is solved. And what is a square minus x square? A square is minus x square is under the root. A square minus x square is nothing but your y. So y into dy by dx, we got it. And you bring this to the right left hand side, it becomes plus x. Problem is solved. So this becomes what? I'll do like this. I'll rub this. So by cross multiplying, we have got, he wants y. So this is, that is y into under the root, y into dy by dx equals to minus x. I've taken one more step. I could have done it at the same step, but let me think. Since a square minus x square equals to y, so I replace this. So y has come here. That is y into dy by dx. I'll move this towards the left hand side, plus it becomes plus. On the right hand side we will have. So don't you think you have got answer? What do you want? Y into dy by dx plus x equals to 0. Y into dy by dx plus x equals to 0. Problem is solved. Very simple problem. So if your examiner is good enough for you, kind, he may give this for 4 marks, or if I am the examiner, I will give this for 2 marks. So let us see, it depends on the examiner. Steps are very simple. You have to recognize the problem and try to do it. Once you recognize the problem, it will be very easy to solve. Differentiation is all about thinking. Just think how to do it. So as it is, you have to bring all the problems to a standard form and differentiate here. But here you have to use your mind to bring it to a simpler way, recognize the problem and apply dy by dx and solve it. Over. So we'll go for next problem. We are given a problem, if x into y equals to 4, prove that x into dy by dx plus y square equals to 3y. So this problem looks very tricky, but it's a very easy problem and it's simple. Only thing you need to know, little bit tricks, and you have to be smart enough to pick it up, how to do it. So dear students, just watch this. It will be a very interesting problem and you really love it. Okay. Now dear students, we are given what? We'll start solution. Given what? X into y equals to 4. I call this equation 1, or x equals to 4 by y or 4 by y or y equals 4 by x. 4 by x. How? By cross multiplying. What we'll do is, we have to see, I told you, you have to follow the hint here. What he has given? He has asked you dy by dx. So catch hold of this and differentiate. So we have y equals 4 by x. 4 by x. Therefore, dy by dx equals to what? D by dx of 4 by x. 4 by x. So what happens to this? That is dy by dx equals to 4 into d by dx of 1 by x, which is nothing but 4 into, if you differentiate this, it goes to numerator. If it goes to numerator, it becomes minus 1 x to the power of minus 1. So minus 1 into x to the power of minus 1 becomes x to the power of minus 2. So therefore it becomes minus x to the power of minus 2. Isn't it? So this means that is 4 by minus 4 by x square. That is our dy by dx. So what we have to do is substitute the value of dy by dx in this equation. That is the only alternative left to you. What we'll do, I'll call this as equation 2. I'll rub this. Value of dy by dx equals, are right here, dy by dx equals to minus 4 by x square in equation 2. That is x into dy by dx is minus 4 by x square plus y square, isn't it? So what you do here, you will try to bring all these values in terms of y, because if the moment you bring it in terms of y, convert this x terms into y terms, so that you will be easy, it will be easy for you to do this problem. So what happens here? What is x? Now given xy equals to 4, x equals to 4 by y, or y equals 4 by x. So what is x here? I substitute the value of x as 4 by y, which means to say that is x is 4 by y minus 4, I will write this by x into 1 by x plus y square. Can I write like this? What I have done, I have split this x square into, because I have that in terms of x. So this becomes what? So this becomes 4 by, okay, I will write there. Right, x equals to 4 by y, y equals 4 by x. I will write this. So this is, which implies 4 by y into, what is 4 by x? 4 by x is y into 1 by x. Now you want 1 by x. So how you get this? By cross multiplying this. So this becomes y by 4 equals to 1 by x, right? So this becomes y by 4 plus y square, correct? So minus sign is there, put minus sign here, minus sign. So that is equals to 4 by y, this becomes minus y square by 4 plus y square, correct? So if you multiply this, follow this, y by 4, y equals 4 by x. So here we are left with 1 by x. If you want 1 by x means by cross multiplying y by 4 equals 1 by x. So this becomes y by 4. So take LCM now. That is 4 by y, 4 by y, 4 is the LCM, 4 is LCM, minus y square plus 4y square. So what happens here? That is equals to 4 by y minus y square plus 4y square becomes 3y square, 3y square by 4. I'll write it here. So here this y cancels and this 4 and 4 cancels. So 4 and 4 cancels and y cancels. So 3y. We left with 3y. What is this 3y? There is nothing but this. And right hand side we have 3y, that is LHS equals RHS, which means to say that x into dy by dx is equals to plus y square equals to 3y, hence proved. This is the answer. See, such a simple problem, you can do it. So dear students, we have next problem, y equals log of, we have y equals log of root x plus 1 by root x. How to go about it? So here this doesn't fall under any standard rule. So we have one concept, that is log rule, that is log of a by b is log a minus log b. We may have to use this rule to solve this problem. I'll teach you how to go about it. So when I take a logarithm, that time I'll teach you in detail, but now you try to know what is required. So this can be written as what? I'll simplify this. This becomes log of root x plus 1 by root x. So what I'll do, I'll take LCM, that is log of, I'll take this as 1, so root x is LCM, so it goes one time, 1 into root x into root x, so that becomes x plus 1. How you got this? That is root x into root x equals to x. Remember this, I've used, it goes root x times root x into root x becomes x. So we got this. So now this is of the form, that is this is of the form log a by b, which is nothing but log a minus log b. So this is the form log a by log b, so that becomes the solution for that is log a minus log b. Log a minus log b can be written as log a by b. So I'll teach you more about this when I am handling logarithm for you. Now you try to know this. So what I'll do next step, or this is therefore y equals to log of, that is x plus 1 minus log of root x. So this equation I call this as equation 1. So equation 1 becomes log x plus 1 minus log root x. So log root is nothing but 1 by 2x. So this is, that is y equals to log of x plus 1 minus log root x. Therefore that is dy by dx equals to d by dx of log of x plus 1 minus log of root x. So we are differentiating this. So what happens here? If we differentiate this becomes 1 by x plus 1 into d by dx of x is 1, let's forget it, and this becomes 1 by 2x. So if we differentiate this, it becomes 1 by 2x. Now we'll take LCM. So that is equals to 2x into x plus 1. So LCM. So it goes one time. So you left with 2x minus x plus 1 time. Done. This is our dy by dx. So we'll remove the bracket and solve this. This is equals to 2x minus x minus 1 by 2x into x plus 1. So here 2x minus x is x minus 1. I'll rub this. So this is equals to, that is dy by dx equals to 2x minus x is x minus 1 by x minus 1 by 2x square plus 2x. So I'll take common, I'll take 2x common, okay, I like this. So we'll leave in the same way, x minus 1, 2x into x plus 1. Therefore, dy by dx equals to x minus 1 by 2x into x plus 1. This is the required answer. So dear students, we are given y equals half log of 1 minus cos 2x divided by 1 plus cos 2x. So we are going to take some problem on trigonometric function also. This trigonometric function where you have to solve these problems. So I have not taught you trigonometry yet, but for this problem I am going to use some trigonometric trick to show that this can be solved using trigonometric function. So in the later class I will be handling some problems, more problems on trigonometric functions also. So now what is 1 minus cos 2x? So I show you what is. Make a note of this. Note. Sin square x equals to 1 minus cos 2x by 2. So remember this formula. Therefore, that is, if you cross multiply, this becomes 2 sin square x equals to 1 minus cos 2x. So we got 1 minus cos 2x, you can substitute as 2 sin square x. Okay. So and we have 1 plus, now 1 plus cos x. Cos square x equals to 1 plus cos 2x by 2. Okay, or that is 2 into cos square x equals to 1 plus cos 2x. So by cross multiplying. So remember this formula is very important. So what I will do, I will substitute the values of 1 minus cos 2x there as 2 sin square x and here 2 cos square x. So what happens to this equation? I call this equation as equation 1. Substituting the values in equation 1, we get, what? Y equals to half log of, that is, I write this 1 minus cos 2x as 2 sin square x, 2 into sin square x divided by 2 cos square x. So equation 1 becomes what? This here, this 2 cancels, we are left with sin square x and cos square x. So sin square x by cos square x is what? Tan square x. So I rub this, that is y equals to half log, so this becomes sin square x by cos square x. I rub this, so this is nothing but half log tan square x equals to what? Log of tan x. So therefore y becomes log of tan x. Now we will differentiate this. See, we have reduced this equation from where to where. So we have taken this 1 minus cos 2x as 2 sin square x, and this is 1 plus cos 2x as 2 cos square x by 2. So that has become half log sin square x by sin square x by cos square x. So that becomes half log tan square x. So that reduces to log of tan x. So if you differentiate this, what happens? Therefore dy by dx equals to d by dx of log of tan x. So I differentiate this. What happens is, this is dy by dx equals to log of tan x is 1 by tan x, 1 by tan x. Differentiation of tan x is secant square x. So this becomes secant square x. See dear students, here we should know formulas by heart. If you don't know formulae, you cannot do anything. If you don't know the differentiation of tan x, no use of doing this problem. So I warn you, go to my class number 1 or 2, there you get some details, some list of formulae where you have to memorize. So now what we will do, what is tan? This can be written as 1 by, can I write like this, sin x into cos x. Okay, so this becomes what? Into secant square x. So cos x I send above, this becomes what? Cos x by sin x into secant square x. So what is secant square x? Secant square is nothing but 1 by cos square x, because the reciprocal of secant square x is nothing but 1 by cos square x. So I'll rub this. So this can be written as cos x by sin x into 1 by cos square x, since secant x equals to 1 by cos x, reciprocals, they are the reciprocal of. So this becomes, since it is secant square x, or secant square equals to 1 by cos square x. Note this. So I have used that relation, I have reduced this. So I'll rub this. Please make a note of this. Okay, I'll rub this now. Okay. So what happens here? Cos x and cos square x, we are left with what? 1 by sin x into cos x. Note, sin 2x equals to 2 sin x into cos x. Sin 2 theta equals to 2 sin theta into cos theta. Equation 2. So this is the equation 2, that is dy by dx equals to 1 by sin x into cos x. So now you want 2 cosecant of 2x. How do you get this? We know that sin 2a equals to 2 sin a into cos a. Right? We'll multiply this equation. I call this as equation 3. Divide and multiply equation 3 by 2. What happens? Dy by dx equals to 2 by 2 sin x into cos x. If you cancel, we get sin x and cos x. So I am dividing and multiplying by 2. What is 2 sin x into cos x? Is nothing but sin 2x. So I replace this as, this is nothing but what? 2 by sin 2x. This is nothing but sin 2x, which is nothing but from this relation. So sin 2x. So 2 sin x into cos x, I have replaced that with sin 2x. What is the reciprocal of sin x? Reciprocal of sin x is nothing but cosecant x. So that becomes 2 cosecant 2x. So this can be written as, I love this. So dy by dx equals to 2 by sin 2x, but sin x equals to 1 by cosecant x, or cosecant equals to 1 by sin x. So what happens to this thing? So that is dy by dx equals to 2 into cosecant 2x, hence root. What I have done? I repeat, I have taken this dy by dx equals to 1 by sin x cos x, but we want 2 cosecant of 2x. So how to go about it? So what I do, we have a relation sin 2x is equals to, or sin 2 theta only, you take whatever you want, you will take sin 2 theta, sin 2 theta equals to what? Sin 2 theta, 2 sin theta and cos theta, but here we have only sin x into cos x. So what I will do, divide and multiply by 2, so that this becomes divide and multiply 2 and 2 here. So 2 sin x theta into cos theta is nothing but sin 2 theta. That's what I have done here. So what I have done, 2, this becomes sin 2x. This becomes, and the moment you multiply this with 2 and this is 2 divided into, this becomes what? This is nothing but sin 2x. This becomes what? Sin 2x. That's what I have done here. So I have divided and multiplied, so this has become sin 2x because of this factor. And later on, what is the reciprocal of sin x? Is nothing but the reciprocal of sin x is 1 by cosecant x. But now we have in denominator sin x, that is in denominator we have, that is 2 sin x. So the reciprocal of that becomes what? 2 cosecant of 2x. So this becomes cosecant. So therefore dy by dx equals to this. Therefore dy by dx 2 cosecant of 2x, hence root. 2 cosecant of 2x, hence root. So the solution is very easy. So dear students, somehow it has come in between. So I have to do log problems anyway. This is also a log problem, but I have tried to teach you something in between. Learn this. When I am doing more on trigonometric functions, you will be knowing it. So in between I will show you how a trigonometric problems and trigonometric ratios look like. So dear students, please make a note. So dear students, we have another problem. Y equal to x into under the root x square plus 1 plus log of x plus under the root x square plus 1. So here, please observe here. Here it is a product of two. It's a product rule, product of two functions, and this is a composite function. So let's differentiate this. Very simple problem. Only thing, It is a simple problem. Only thing you should know how to differentiate this. So what we'll do is we'll differentiate this. Dy by dx equals to first, that is d by dx of, I'll repeat the problem, x into x square plus 1 plus log of x plus under the root x square plus 1 and close the bracket. So here we have to use product rule, and this is a composite function. So this is equals to what? I'll solve this. That is equals to, I keep this first function as it is, and d by dx of x square plus 1 plus x square plus 1 into d by dx of x. This is pertaining to this part. Now plus d by dx of, so I'll differentiate this as it is, let's not bother. So what happens to this? So differentiation of this will be, okay, one step we'll write, no problem. D by dx of x plus x square plus 1. One step I have written, no issues. This is d by dx of x, correct. Okay, so what happens to this? This becomes x into, this is half. If you differentiate this, x square plus 1 into 2x plus, that is x square plus 1 into, differentiation of this is nothing but 1 plus, this will be, differentiation of this will be 1 plus under the root, sorry, this is c, d by dx of log, this is d by dx of log x plus under the root x square plus 1. So make a change there, sorry for that. So this will be what? If you differentiate this, this will be 1 by x plus under the root x square plus 1. So the entire portion has come down. Now I will put a for bracket. So differentiation of this will be 1 plus under the root half x square plus 1 into d by dx of the inner function, that is into 2x. Okay, it's a lengthy problem, no issues. So here this 2 cancels, and this becomes what? X square by this is x square plus 1 plus x square plus 1. So this is one by x so here 2 and 2 cancels, 1 plus x by under the root x square plus 1 Please make a note. So I rub this. I rub this too. So this is equals to what? X square by under the root x square plus 1 plus x square plus 1 plus one by x plus x square plus 1 into, I will take LCM here. So what happened? What is LCM here? X square plus 1 is a LCM. So this becomes what? X square plus 1 plus x I'll rub this. So what I'll do? I'll take LCM here. That is equals to x square plus 1 is LCM here. So it goes here one time. This is x square plus 1 goes there, x square plus 1 time. So this is x square plus 1 time into x square plus 1 time becomes under the root x square, that is we have root x into root x equals to x. So here we have root x plus 1, root x plus 1, it becomes, see here we have into root x equals to x. So here we have x square plus 1 into x square plus 1 equals to x plus x square plus 1 we get. So once we multiply, so what happens here? It goes x square plus 1 times. So x square plus under the root x square plus 1 goes, multiply this and this becomes what? X square plus 1, root vanishes off. So the root is gone. Equals to, plus 1 by x plus under the root x square plus 1. So I will rearrange this. So this becomes what? X plus under the root x square plus 1 divided by under the root x square plus 1. Done. I'll rub this. So what happens to this? No, this becomes 2x square plus 1. 1 by under the root x square plus 1. Plus, see here, x plus under the root x square plus 1, x plus under the root, this and this cancels. So I left with what? 1 by x square plus 1. I take LCM. that is under the root x square plus 1. So this is 2x square plus 1 plus 1. So what I'll do this equals to 2x square, 1 plus 1 is 2 by under the root x square plus 1, which is nothing but, I take 2 common, that becomes x square plus 1 by under the root x square plus 1. So dy by dx equals to 2 into x square plus 1 by under the root x square plus 1. What I'll do is, now supposing you have x here and root x here. Okay, you take this. So what I'll do, can I write like this? This x can be written as what? Root x into root x divided by root x. Can I write like this? Because root x into root x is x divided by root x. So what happens here? This and this cancels, you are left with root x. So what I'll do, similar way, this is nothing but 2 into, okay, I'll write here. So this is nothing but 2 into square root of x square plus 1 into x square plus 1 divided by this x square plus 1. Can I write like this? Because of this logic. So what happens here? I'll cancel 1, I cancel 1. So left hand side we have dy by dx equals to what? 2 into under the root x square minus x square plus 1. What do you want? Prove that dy by dx is 2 into under the root x square plus 1, hence proved. Therefore dy by dx equals to 2 into square root of x square plus 1, hence proved. Hence proved. Mark this, it is an important problem. So this teaches you how to solve problems using steps. So this marks in the examination, if you get, definitely 4 marks or 6 marks. Most likely 4 marks you will be getting for this. So dear students, we will go for the next problem. It was a nice problem. So you have to apply yourself, work it out very patiently with a cool mind. Open the YouTube channel, sit beside it and try to work it once or twice. If you can understand the steps properly, you are through with it. You will be able to solve problems quite similarly. So we will be learning more of these problems in future. So I want you to take this very seriously and try to work it out, this problem. So this is very important for you students. Use your head to solve this problem. Okay dear students, I will go for next problem. So dear students, we have one problem. Y equals x by 2 into under the root a square plus x square plus a square by 2 log of x plus under the root x square plus a square. Prove that dy by dx equals to under the root x square plus a square. It is simple differentiation. There is no use of mind here or head here, no tricks. Straight away simplification, and you have to follow the steps. If you know differentiation, you can do this, otherwise you can't. So it will not at all a tricky problem, very simple to do it. Please follow me. The steps are very simple. If you can understand the steps, you can easily do any problems given to you. Definitely this will be for 6 marks. Please follow me. So what I will do, y equals, see, look at this problem. Here you have 1 by 2 and a square by 2. So these are constants, you can take it outside. So don't worry about this. So what I will do in this first case, I will take y equals to this x into a square plus x square. This is one step. Plus what I will do this a square by 2 I will take outside, and this is log of x plus under the root x square plus a square. So this problem I have simplified and I made it easy for you. Now we will differentiate this. Now what I will do, differentiating this. So dy by dx equals to, I will take this half outside, d by dx of, this is a product rule. So x into a square plus x square, I have to use this for this, and here again a square by 2 I will take outside. This will be a square by 2 outside, d by dx of log of x plus x square plus a square. So now I think you can easily simplify this. So what I will do here, I will use this a product rule. So I will keep this first function as it is, x as it is, this is d by dx of a square plus, I keep the second function as it is, that is a square plus x square as it is into d by dx of x. So this part is over, first part. Now we have to use the second part, that is a square by 2. So differentiation of this is nothing but 1 by, this is x plus square root of x square plus a square, right, this, and differentiation d by dx of t by dx of, this is x plus square root of x square plus a square. Done. So I will cross check this. First half I have taken x as it is, differentiate this, and I get this function and d by dx of x over. So a square I have taken outside. So differentiation log x is 1 by all this, right, into d by dx of inner function, and later on we will differentiate at x square, so we will do that. So this is nothing but half into, so x into, this becomes what, half a square plus x square, differentiation of this will be 2x plus a square plus x square into 1. Done. Plus a square by 2. So this becomes 1 by x plus under the root x square plus a square. So dy by x, this becomes what? 1 plus half x square by x square plus a square. This becomes dy by dx of x is 1, half of x square plus a square into 2x into dy by dx of x square is 2x. So I have closed the bracket. So here 2 cancels, x into x becomes x square. So that is half, I will write as it is. So this 2 and this 2 cancel, x into x becomes x square by under the root a square plus x square plus a square plus square. Now we will come to this plus a square by 2. So again here 2 and 2 cancels. So this becomes 1 by x plus under the root x square plus a square. So this becomes what? 1 plus x by under the root x square plus a square. Please follow the steps. It's very simple. Rub this. I will take LCM here for this also. So this is equals to half. So this is under the root. I will write still this side so that I need space. So this is a square plus x square, goes one time. This is x square plus 1 into this. What happens? 1 into a square plus x square into this becomes a square plus x square. Root gets cancelled because 1 into this becomes under the root a square plus x square into a square plus x square becomes a square plus x square. Done. So this part is over. Plus a square by 2. So this is 1 by x plus under the root x square plus a square. I will take LCM. This is LCM is under the root x square plus a square. So we have 1 here. So this becomes what? Under the root x square plus a square plus, it goes one time, plus x. So here we have left with what? 1x square plus 2x square. That is 2x square plus a square by under the root a square plus x square plus a square by 2. So I rearrange this. So this is 1 by x plus x square plus a square. I write this x plus under the root x square plus a square divided by under the root x square plus a square. So and this square bracket. So what happens? We have x plus under the root x square plus a square, x plus is this and this cancels. I rub this. So that is nothing but half into 2x square plus a square divided by a square plus x square plus a square by 2. So we have 1 by under the root x square plus a square. So dear students, what I'll do here is I'll write this half, this is 2x square plus a square by under the root a square plus x square plus I write this a square by 2 into, I will rewrite this as a square plus x square. Whether it is a square, because you have a plus sign here, either you can write x square plus a square or a square plus x square, both are same. So I rub this. So what is common here? I take this, I'll take LCM here, that is a square plus x square. So this becomes 2x square plus a square plus again a square. So which implies half into 2x square 2a square plus 2a square divided by under the root a square plus x square. I take this common 2. So what I'll do is I take this 2 is common here, so this is equals to half 2 common, this is x square plus a square divided by under the root a square plus x square. So this 2 cancels. So left with what? On the left hand side we have dy by dx, equals to x square plus a square divided by, in this x square plus a square. Well, a plus b, the a square plus b, a square plus b square is nothing but b square plus a square, both are same. Since we have addition sign, a plus b equals b plus a, so no issues. So I rub this. So now what I'll do is, we know that root x into root x is nothing but x, or x can be written as what? Root x into root x. Likewise, we have x square plus a square. Can I write like this? Under the root x square plus a square into so what I will do is, this can be written as x square plus a square into x square plus a square divided by under the root x square plus a square. I have said this, root x or root x, x can be written as root x into root x. Similarly, this I have written under the root x square plus a square into under the root x square plus b is nothing but this value. So this and this cancels, you are left with what? We are left with what? I will rub this. So I am left with what? Which implies dy by dx equals to under the root x square plus a square. So what we want? We want dy by dx equals to under the root x square plus a square. We have got it. So therefore, I rub this. Therefore, dy by dx equals to under the root x square plus a square, which is hence proved. So dear student, there is no difficulty in this problem, there is no tricks in this, simple differentiation, and you have to solve the steps, that's all. If you can solve this on your own, you are good in differentiation, you have learned something out of my teaching. So dear students, please note down this and try to work it out again once or twice without seeing the book, you will pick it up. So we will go for the next problem. So dear students, we will take next problem. Y equals to under the root sine of under the root 1 plus x square. So this is a very simple problem. So we have to differentiate straight away. We will see how to differentiate this. So here this doesn't involve any standard form, it is straight away. You have to differentiate this with respect to x. So that is dy by dx equals to d by dx of under the root sine under the root 1 plus x square. So this is how the problem is. So what we have to do here, see what you need to do. First, try to recognize the trick behind the problem. So don't straight away jump into solving the problem. So first we know d by dx of under root, anything it is nothing but half root of that. That is, so this is half of, let us see how to go about it. I will show you. So this is equals to what? First we will write half of under the root, this is sine under the root 1 plus x square into d by dx of sine 1 plus x square. So first what you do, whatever is given the function, take that half of that into write as it is, and then later on d by dx of the inner function, and later on we have d by dx of this, we will do in different stages. So what happens to this? This equals half under the root sine of 1 plus x square. So this becomes d by dx of sine is nothing but cos of under the root 1 plus x square. So you differentiate this. Now d by dx of under the root 1 plus x square. Done. So that is equal to, we'll go for next thing. I'll divide this. So this is, we'll try to rearrange this. So on the left hand side we have dy by dx equals to, this is half into this cos of, this becomes 1 plus x square. This is under the root, sorry, this is under the root sine of under the root 1 plus x square. Now this is our dy by dx of this. So into dy by dx of this becomes what? I'll open this bracket. So this becomes half into root of 1 plus x square. Then d by dx of x square is 2x into 2x. Close the bracket and we have a square bracket here. So square bracket. So what happens here? This is equals to half cos of under the root 1 plus x square by under the root sine under root 1 plus x square. So this is, so this becomes 2x by 2 into under the root 1 plus x square. So this two cancels. I left it what? Half, you write as it is. This is cos of 1 plus x square by under the root sine of under the root 1 plus x square. Done. Into x under the root 1 plus x square. Done. So this is nothing but, I'll bring this x this side and this portion, that is half, I'll write this as it is. This is x square under the root 1 plus x square into cos under the root 1 plus x square by under the root sine under the root of 1 plus x square. I write to rearrange this. On the left hand side we have dy by dx equals to, I will write this x into cos of 1 plus x square divided by 2 into 1 plus x square into under the root 1 plus x square. Therefore dy by dx equals to x into cos of under the root 1 plus x square divided by 2 into under the root 1 plus x square into sine of 1 plus x square. So I will put this within the bracket. This is the required answer. So students, though the problem looks a bit complicated, but it is not so. Only thing, you have to know the steps and how to solve this. So without wasting our time, we will go to our next problem. Dear students, we are given one problem, y equals to log of under the root 1 minus cos x divided by 1 plus cos x. I remember in the previous class I have done one problem on log of 1 minus cos 2x divided by 1 plus cos 2x. This is half angle. I will teach you how to go about it. So this can be written as, I will show you. So or y equals to log of under the root 2 sin square x by 2 divided by 2 cos square x by 2. Because how you got this? In the previous class we know that sin square x equals to 1 minus cos 2x by 2. By cross multiplying it becomes 2 sin square x equals to 1 minus cos 2x. This is a full angle. But what we want? We want 1 minus cos x. Here it is 1 minus cos 2x. So this is one minus this cos 2x. But 2 sin square x by 2 equals to 1 minus cos x. So these are half angles. So similarly cos square x equals to 1 plus cos of 2x by 2 or 2 cos square x equals to 1 plus cos of 2x by cross multiplying this. Okay, and 2 cos square x by 2 equals to 1 plus cos of x. So we have substituted this using this relation. I have straight away written this. In the examination you have to mention this, how you got 1 minus cos 2x, 2 sin square x by 2, because we have to mention this, at least this. So what happens to this? So this becomes what? This becomes log of under the root. So this 2 cancels. Sin square x by 2 divided by cos square x by 2 is nothing but tan square x by 2, right? Or y equals to, so I want or y equals log of tan x by 2, because tan square becomes tan x by 2 once it comes out of the root. Now we have got y equals to log of tan x by 2. Now we can differentiate this. So I'll rub this. I hope you have made a note of this. Yes. So we have got y equals log of tan x by 2. So differentiating this, dy by dx equals to d by dx of log tan x by 2. So if you differentiate log tan x by 2, what you get? This is 1 by tan of x by 2. We get this, whatever we have associated with log, we get that at the denominator, and differentiation of, and d by dx of tan x by 2. Done. So that is equals to 1 by tan x by 2 x by 2. This becomes tan d by dx of tan x is secant square x. So this becomes secant square x by 2. So I rub this. So this can be written as what? In the previous class we have done this. So this can be written as 1 by tan is sin x by 2 divided by cos x by 2 into secant square x by 2. X by 2 in the sense it is half angles. So I'll teach you when you are doing compound angles. So what happens is cos will go to the numerator, that becomes cos x by 2 goes to denominator, so numerator, and this sign remains in the denominator, into what is secant square? The reciprocal of secant square is 1 by cos square x. So this is 1 by cos square x by 2. Since I rub this, since secant x equals to 1 by cos x. So the secant x becomes 1 by cos square. Since it is secant square x by 2, it becomes 1 by cos square x by 2. So here 1 cancels and 1 this goes. So what we have? We get what? 1 by, that is our dy by dx. Okay, we'll write next line. So y by sin square x by 2 into cos x by 2. Okay, did you follow? This is our dy by dx. So what I'll do is I'll divide this numerator divide and multiply. This I call this as equation 1. Divide and multiply equation 1 by 2. We get what? Dy by dx equals to 2 by 2 into sin x by 2 into cos x by 2. I'll rub this. So here note sin 2 theta equals to 2 sin theta into cos theta. So we have 2 sin theta into cos theta. Similarly, that is 2 sin of x by 2 into cos x by 2. So this is nothing but sin 2, I show you this, or sin 2 theta by 2 equals to 2 sin theta by 2 into cos theta by 2. So I will substitute this value. So I call this as equation 2. Equation 2 becomes what? Dy by dx equals to 2 by sin theta by 2. So, sin 2 theta by 2, sorry. Sin 2 theta by 2. What is the reciprocal of sin theta? 1 by cosecant theta. So I'll write here. Therefore, dy by dx, if you want you can stop at this, or you can stop even at this also, no problem, but I want to bring it to a similar problem. I am trying to relate it to the previous problem, that's why I am going one step ahead, otherwise you can straight away stop at this. So I remember that, prove that this is equals to 2 cosecant 2x. Remember, I am going to bring it in similar form. So this becomes what? 2 into cosecant 2 theta by, sorry, it is x. All these problems are in terms of x. So replace this by x. So this becomes 2 x by 2. So dear students, this is nothing but an extension of trigonometric function. So you have both log as well as trigonometric function. So I want you to get equipped with these problems, that's why I am adding few problems in between. So later on we will try to do some problems on trigonometric functions and inverse functions. Let us see how to go about it. We have to plan and do it accordingly because I have lot of portions to cover. So please make a note of this. It's quite simple and easy to follow. So we'll go for the next problem. So dear students, we'll do this, that is dy by dx equals to d by dx of log of cosecant x minus cot x. So it's a simple problem. We should know the formulae for this, otherwise you can't proceed. So once again, whenever I see some trigonometric equations or functions, I keep reminding you to learn formulas from my YouTube, that is class number 1 or 2. I have given a list of formulae. Try to prepare that and try to keep it on your fingertips. Whenever you get problems on trigonometric relations, trigonometric functions, you have to recall those formulae and try to apply here and solve the problems. Otherwise, no use doing this problem. So I hope you will follow this. So let's differentiate this. So as usual, when you differentiate long function, whatever you have in the parenthesis, that is in the brackets, bring it down. So this becomes what? 1 by, this becomes cosecant x minus cot x, right, into d by dx of whatever in the parenthesis, that is cosecant x minus cot x. Okay. So now this is equals to what? 1 by cosecant x minus cot x. So I'll use the bracket. D by dx is nothing but a difference rule. So you have to say, I'll do it separately. That is d by dx of cosecant x minus d by dx of cot x. Okay. This is a sum rule, that is difference rule. So what I have taught you in the previous class. So let us differentiate now. I'll rub this. Yeah, I'll rub this. dy by dx equals to 1 by cosecant x minus cot x. So I have written this d by dx of cosecant x is what? Minus cosecant x into cot x. So d by dx of cosecant x is minus cosecant into cot x, done, minus d by dx of cot x is nothing but minus cosecant square x minus cosecant square x. See the formulas. So remember these formulas, it is very important. If you don't remember the formula, you can't do anything. So I rub this line. So this is nothing but 1 by cosecant x minus cot x. I will put a bracket for this. So here minus into minus plus. So here you have a minus sign, minus cosecant x into cot x plus cosecant square x. So how you got this plus? multiplying the minus into minus becomes plus cosecant square x. I'll rub this. So I'll rearrange this within the parenthesis. So within the brackets I'll rearrange. That is equals to means 1 by cosecant x minus cot x. So first I'll write this cosecant square x minus cosecant x into cot x. I rub this. So now what is common in this? Cosecant x is common. So I'll take that cosecant x outside. So what I'll do is, first I'll write this as it is, that is 1 by cosecant x minus cot x. So I'll take cosecant x common. So what happens here? We have 1 cosecant x minus cot x. See here, we have cosecant x minus cot x and cosecant x cot x. This and this cancels. So that is equals to, so this and this cancel, left with what? Cosecant x. Therefore dy by dx equals to cosecant x. This is your answer. So dear students, we have a problem y equals log of under the root x minus 1 by x plus 1. This can be simplified, that is log of, so this can be written as x minus 1 by x plus 1 whole to the power of half. Can I write like this? So this root is replaced by root. So nothing but square root of this becomes, I have told you, if we have square root of x, that is nothing but x to the power of half. So we have a square root. So this square root is common to both numerator and denominator. That's why you get the power of half. So this becomes what? Half log x minus 1 by x plus 1. Okay. So let me divide this into two parts. So now this is of type log a by b. So what I'll do is, this is of the form log a by b, which is nothing but log a minus log b. So if you want to put this in brackets, log a minus log b. So we'll learn about logarithm in the coming days. So now we'll limit our knowledge. Whatever is required for this problem, I'm going to handle it and teach you. So now this becomes what? So y equals to what? Half I take like this. This becomes log a. Log a is nothing but log of x minus 1 minus log b, that is x plus 1. Done? Okay. Now we have got this y equals to this one. Now we can differentiate this because it's easy to differentiate now. So what happens is, dy by dx equals to, I'll take this half outside, so this becomes dy by dx of, that is log of x minus 1 minus log of x plus 1. Okay. Now this is the thing, but half I will write like this. This will be d by dx of log x minus 1 minus d by minus, because half is common for both, minus d by dx of log x plus 1. Okay. So what happens to this? D by dx of log of x minus 1 becomes whatever is within the bracket, that has to come down. So this is equals to half, I write as it is. So this becomes 1 by x minus 1 minus 1 by x plus 1, right? So this portion has come down and this portion has come down. So what I'll do next step, I'll take LCM. So that is equals to half, I'll take outside. So this is x minus 1 into x plus 1. So x minus 1 is here. So we will get x plus 1 minus, this becomes x minus 1. How did you get this? So x minus 1, x minus cancels, you are left with x plus 1. So x plus 1 you have gone to the numerator. So minus sign, minus sign. So you have x plus 1, x plus 1 remove this, x minus 1 you get. So we will simplify this. This becomes half into, we will remove the brackets, x plus 1 minus x, okay, I'll remove the brackets straight away, why to waste my time. This is x plus 1 minus x, minus into minus, plus 1 divided by x minus 1 into x plus 1. So plus x minus x cancels, done. So this becomes what? Half by plus 1, that is 2 by x minus 1 into x plus 1. So this 2 and this 2 cancels. I rub this. So on the left hand side we have dy by dx equals to 1 by x minus 1 into x plus 1. Okay. We can stop at this, or this is a plus b into a minus b, that is a square minus b square. We can write like that also. That is further equals to 1 by x square minus 1. Since a plus b into a minus b equals to a square minus b square. So if you want, you can write 1 square. Therefore dy by dx equals to 1 by x square minus 1. This is the required answer. So dear students, we have one more problem. Y equals log of x plus 2 plus under the root x square plus 4x plus 1. It's also an easy problem. We'll see how to go about it. So we'll straight away we'll differentiate this. So what happens here? dy by dx equals to d by dx of log of, that is x plus 2 plus under the root x square plus 4x plus 1. So there is no need of the floor bracket anyway. So as we know, whenever you get log x, whatever is there associated with log, bring it to the denominator. So that becomes what? 1 by x plus 2 plus under the root x square plus 4x plus 1, then d by dx of, then d by dx of, that is x plus 2 plus under the root x square plus 4x plus 1. So here it is a sum rule. So we have to differentiate this. So what happens here? This equals to 1 by x plus 2 plus under the root x square plus 4x plus 1. So d by dx of x is 1 plus this is 0 plus half into this is x square plus 4x plus 1 into d by dx of x square is 2x, d by dx becomes plus 4 equals to, that is equals to 1 by x plus 2 plus under the root x square plus 4x plus 1. So I'll use this. So this is 1 plus 0 plus half into square root of x square plus 4x plus 1. Here we have left with 2x plus 4. Okay. This is 1 by x plus 2 plus under the root x square plus 4x plus 1. So I remove at 0. So that is 1 plus, I take 2 common, that is x plus 4, x plus 2, sorry, x plus 2, I have taken 2 outside common, and here you have 2 into under the root x square plus 4x plus 1. So this 2 cancels. So this equals to 1 by x plus 2 plus under the root x square plus 4x plus 1. So I take LCM here. So what happens here? So LCM is under the root x square plus 4x plus 1. So it goes one time 1 into this, 1 goes this, that is under the root x square plus 4x plus 1 plus x plus 2. I'll rub this. So I'll rearrange this. That is our left hand side. Dy by dx equals to one by x plus 2 plus under the root x square plus 4x plus 1. So I rearrange this. X plus 2 plus under the root x square plus 4x plus 1 divided by under the root x square plus 4x plus 1. I rub this. So what happens? We have x plus 2 plus under the root, here also x plus 2 under the roots, and this. So this and this cancels. So you are left with what? 1 by under the root x square plus 4x plus 1. What is this? This is our dy by dx. I'll rub this. Therefore, dy by dx equals to 1 by under the root x square plus 4x plus 1. This is the required answer. Dear students, we have one more problem now. Y equals log of x plus under the root a square plus x square divided by a. Whenever you find a problem, so I am going to give you a hint. So whenever you find a problem where you have both denominator and numerator associated with log, then you use the formula log of a by b, which is log a minus log b. That is a hint for you to follow how to go about it. So what I am trying to do is, before you start doing a problem, I want to give some tricks how to tackle those hidden secrets of a problem. So that I am going to teach you, because that is very important. Straight away don't jump into conclusion and start doing the problems. So here every problem will have its own recognition. So try to recognize the depth of the problem and try to solve it on its merit. So here we have log of x plus under the root a square plus x square divided by a. So this is the form log of a by b. So let's solve this problem. So what I'll do is, I'll take this as log of x plus under the root a square plus x square minus log a. So if nothing is mentioned, it is nothing but to the base e. Okay. Now the since, I'll write the reason, since log of e by b equals to log a minus log b. I use this principle here. So now it is easy to differentiate this. So this is our y. Now dy by dx equals to d by dx of x plus under the root a square plus x square minus d by dx of log a to base c, dx of this is dy by dx equals to d by dx of log this. So this becomes whatever, as I told you, whatever is there within the thing, this becomes what? 1 by x plus under the root a square plus x square, then into d by dx of, so this is x plus under the root a square plus then into d by dx of x square. So minus d by dx of this becomes what? A constant, that is 0. So we'll solve this. I'll rub this. So that equals 1 by x plus under the root a square plus x square. So this becomes 1 plus half of root a square plus x square into 2x. So this 0 I will neglect it. I'll rub this also. Please make a note. You can pause it and make a note of this. So this is equals to what? 1 by x plus under the root a square plus x square. So I'll take LCM. So this 2 cancels. So that is 1 plus xy under the root a square plus x square. So this is equals to 1 by x plus under the root a square plus x square. So LCM is a square plus x square. It goes one time, that is a square plus x square plus x. Done. I'll rearrange this. So after rearranging this, I'll rub this also. So let us rearrange this. So on the left hand side we have dy by dx equals to 1 by x plus under the root a square plus x square. I'll rearrange this. So I write x plus under the root a square plus x square divided by under the root a square plus x square. Done. So note here we have x plus under the root a square plus x square, and in the numerator we have x plus a square plus x square. So this and this cancels. So you are left with what? You are left with 1 by, I rub this, you are left with under the root a square plus x square. Therefore, dy by dx equals to 1 by under the root a square plus x square. This is the answer. So dear students, problems are very simple, very easy, provided you know how to do the steps. So follow the steps very carefully, you will not go wrong. So we will go for the next problem. Dear students, we have one problem. Y equals log of under the root, that root x plus 1, root x minus 1. So I have told you, whenever you get a problem based upon log functions, so what you do, use log a minus log b, that is log of a by b. So here we have log a by log b. So log of a by b is log a minus log b. So we will use that concept here. So this can be written as, that is implies y equals log of root x plus 1 minus log of root x minus 1, since log of a by b equals to log a minus log b. So this concept you can use here. So what happens is, now we are able to differentiate this because it is okay. Dy by dx equals to d by dx of log root x plus 1 minus log root x minus 1. So this is also equals to d by dx of, I will use a square bracket, log of root x plus 1 minus d by dx of log of root x minus 1. So dear students, I hope now it is clear. So you are applying. Now let's differentiate this. So this is nothing but a difference rule. What I have taught you earlier, let's do this. So this becomes what? So whatever is nothing but 1 by under the root x plus 1 into d by dx of root x, because d by dx of 1 is 0, so let's not bother about it. So minus this again 1 by under the root x minus 1 into d by dx of root x. So please make a note of this. So I'll rub the first line and second line too. So what happens to this? This equals to 1 by under the root x plus 1 d by dx of root x is half root x, I'll use a bracket, equals to minus, this is again 1 by root x minus 1, and this becomes half root x. So I'll rub this. So I take 1 by 2 root x outside, 1 by 2 root x outside. What happens here? You get 1 by root x plus 1 minus 1 by under the root x minus 1. Then, now, so what I do is, I will take LCM. I have to solve this. So this is equals to 1 by 2 root x. So LCM is root x plus 1 into root x minus 1. Sorry, this is root x, not full. Just correct this everywhere. I'm used to this, that's why. Okay. Now, root x cancel, we left with, that is root x minus 1 minus n is there. So this and this cancels, so we are left with what? Root x plus 1. So I rub this. So I'll take this, that is equals to half root x. So I'll remove the bracket, that is root x minus 1. So minus root x minus root x, and this becomes minus into plus minus 1 by root x plus 1 into root x minus 1. So here what happens? Half root x. So plus root x minus root x goes. So minus 1 becomes minus 2 by this becomes, this is a plus b into a minus b. So that becomes what? X minus 1. So this 2 and this 2 cancels. We are left with what? 1 by root x into 1 by minus 1. I put that by minus 1 by x minus 1. So this is nothing but minus 1 by root x into x minus 1. You can stop at this, or you can still multiply, that is x to the power of half into x, that becomes 1.5. So it becomes tedious, you can stop at this. So I put this minus sign here, or still to look neat, that is minus 1 by Therefore, dy by dx equals to minus 1 by under the root x into x minus 1. This is the answer. So dear students, we have one more problem. Y equals log of x plus under the root x square minus x square plus 1. So this is a very simple problem if you know the steps and the concept. So let's solve this. I'll show you how to do about this. So first we consider this log function and later on the other function, log function. So we'll differentiate this straight away. Dy by dx equals to t by dx of log of, again we have one log function, that is x plus under the root x square plus 1. So here we are. So let's differentiate this. So this becomes, first we are taking this and differentiate. So before this log and after this log portion, whatever is there, bring it as it is. So this becomes what? 1 by log of x plus under the root x square plus 1. You got this entire portion as it is, you bring it down. We have one more log here. So that is into 1 by, so this becomes x plus under the root x square plus 1. Now differentiate this. So that will be what? Into d by dx of x plus under the root x square plus 1. Got it? So what I did first, this log of, so this log I ignored this and brought this as it is, everything as it is. So this function. So this is here. Okay. Later on I have to differentiate this. So what I'll do is I'll bring this as it is. So this is our 3. So later on d by dx of this. Done? So let us go ahead. So I'll rub this. So what happens here? This is equals to 1 by log of x plus under the root x square plus 1 into 1 by x plus under the root x square plus 1. So into, so use the flow bracket here. So this becomes, you differentiate this, 1 plus under the root 2 x square plus 1 into d by dx of x square, that is into 2x. Got it? So I'll rub this. Please make a note of this. I'll rub this also. So now I'll reproduce it once again, rewrite it as it is. 1 by, this is our dy by dx, dy by dx, this is log of x plus under the root x square plus 1 into 1 by, this is x plus x square plus 1. So I'll use this bracket as it is. So this 2 cancels. So this becomes 1 plus x by x square plus 1. I'll rub this now. So 1 by log x plus root x, yes, 1 by this, yes, into 1 by this 2 x by so and so. Okay, done. So this equals to 1 by log x plus under the root x square plus 1 into 1 by x plus under the root x square plus 1. So here I take LCM. So under the root x square plus 1. So this goes x square plus 1 plus x. Done. So this is equals to what? 1 by log of x plus under the root x square plus 1 into 1 by x plus under the root x square plus 1, and I'll rewrite this. So this becomes what? X plus under the root x square plus 1 divided by under the root x square plus 1. So I close the bracket. See here, you have x plus under the root x square plus 1. Here we have in the numerator x plus under the root. So this and this cancels. So I'll rub this. So you're left with what? So I'll bring this 1 by, I'll write this, I'll write 1 by, first I write this term 1 by x square plus 1. This portion is gone, you're left with what? You're left with this into 1 by log of x plus under the root x square plus 1. And this is, so I rub this. Therefore dy by dx equals to what? 1 by under the root x square plus 1 into 1 by log of x plus x square plus 1. This is the required answer. So note students, this sort of problems are very easy comparatively when compared to other problems, because one function gets cancelled. So it will be easy for you to do this. Whenever, if you are lucky, you will get this and you can easily solve this. So well, this problem is over, we will go for the next problem. I want to do variety of problems so that you are comfortable in differentiation, especially derivative of composite functions. So after this we will go to some other chapter. Let us see what to be done. I want to do justice with you and I will do it. So meanwhile, once again I tell you to share my video, like my video and subscribe to my channel. That is important, that's your responsibility, because you can find I am not wasting you in a single minute. I am trying to give you the best and without wasting my time and your time. So it should be fruitful to you, it should be beneficial to you, because I want every second of yours to be utilized. I don't want to waste my time like other lecturers. Simply they do few problems on the board and they waste time talking to you all and wasting time. So dear students, here we are given a problem y equals to x plus under the root 1 plus x squared to the power of m. So the moment you see this, you will be surprised. What is this? You have something like this and to the power of m. So don't get confused here, because this is quite similar to d by dx of x to the power of n. Whether it is n or m hardly matters, but the procedure is the same. So dear students, don't be carried away or don't be get confused. So this is a very simple problem. Use the concept what I have taught you, d by dx of x to the power of n, same thing, and proceed. So this is very interesting. Let's do it. So we'll differentiate this. Dy by dx equals to what? I'll take this m into x plus under the root 1 plus x square to the power of m minus 1 into d by dx of, that is this portion, x plus under the root 1 plus x square. So we'll do this little later, because we have to differentiate this also. We'll see how to do it. So here this is of what we have learned. D by dx of x to the power of n is what? N into x to the power of n minus 1. The same concept I am going to use here. So that's what I have used also. So whether it is m or n or p, whatever it is, try to use it, that concept, and proceed. So what happens here? We'll solve this. So this becomes what? Next step, m into x plus under the root 1 plus x squared to the power of m minus 1 into, so this becomes d by dx of this, that is 1 plus half of 1 plus x square into d by dx of x square, that is 2x. I have differentiated x square also. Okay, let us not waste one step, it is understood. So we'll solve this. This is equals to m into x plus under the root 1 plus x square to the power of m minus 1 into, so this 2 cancels, so I left with 1 plus x by under the root 1 plus x square. So I'll rub this. We'll take LCM here. So that is equals to m into x plus under the root 1 plus x square to the power of m minus 1. So we have LCM is under the root 1 plus x square. So we take 1 here, this goes one time, that is 1 plus x square plus x. I rub this. Have you followed? See what I have done? 1 LCM is 1 plus under the root 1 plus x square. So we have 1 goes this time, that into this multiply, we get this. So I repeat, we have got LCM as under the root 1 plus x square, and here we have 1 goes this under the root 1 plus x square times, that into 1 is 1 plus under the root 1 plus x square, as it is repeated, and this goes one time, 1 into x is x. So you have got back this. So what I will do, so here what do I do? I will rewrite this once again. So what I will do, m by under the root 1 plus x square. Can I write like this? And later on I will write this. This is x plus under the root 1 plus x square, 1 plus x square to the power of m minus 1 into, I will rewrite this, I interchange this, I write this x plus under the root 1 plus x square. I have removed this and I brought it here. So here this is to the power of 1. See here, the bases are same, isn't it? X plus under the root 1 plus x square to the power of m minus 1 into x plus under the root 1 plus x square. So bases are same, add the indices. What happens here? This becomes m into under the root 1 plus x square. So this becomes what? X plus under the root 1 plus x square. This is m minus 1 plus 1. Bases are same, add the indices m minus 1 plus 1. So minus 1 plus 1 cancels. So I'll rub this. So what happens here? That is m into 1 by 1 plus x square, m by under the root 1 plus x square into x plus under the root 1 plus x square to the power of m, right? Now what is this? This is nothing but our y, because see this? This is our y. So can I write like this? M into y by under the root 1 plus x square. Since x plus under the root 1 plus x square to the power of m equals to y, isn't it? So what he wants? He wants show that 1 plus x square into dy by dx a whole square equals m square into y square. So we have already got this. What is on the left hand side? We have got dy by dx. What he wants? He wants 1 plus x a whole square into dy by dx a whole square. So I'll cross multiply and square both sides. You get answer. Simple. So dear students, I know you are enjoying this problem. Come on, have a smile. This is a beautiful problem. I know you might be wondering how it is. See, cross multiply this. Once you cross multiply, you get this, and you have to square on both sides. Immediately you get answer. Maths is really beautiful. Provide it, you enjoy it. Sit at a table, look at this, and in this spirit you learn mathematics. Really start loving mathematics, and that's what I want you to learn. I want you to learn maths with lot of enthusiasm and interest and with a charming mood. So let's do this. So which is nothing but I'll write like this, by cross multiplying. Cross, what happens here? That is, I want in this style. First I'll write this 1 plus x square into dy by dx equals to, on the right hand side you have my. What he wants? He wants 1 plus x square into dy by dx the whole square equals to m square by y square. How do you get this? Squaring both sides. Now by squaring both sides, we get what? So I'll rub this. So square this, 1 plus x the whole square becomes what? I'll write one step, dy by dx whole square means for this also I have to add square into under the root under the root 1 plus x square the whole square equals to m into y the whole square, isn't it? So what happens to this? This becomes, we want in this side first, I bring this 1 plus, it becomes 1 plus x square, we have already got this, and this becomes dy by dx the whole square into, this becomes equals to m square into y square. Therefore, one plus x square into dy by dx the whole square equals to m square into y square. Hence, proved. I proved this. So, students, very good problem. If I were to be an examiner, I would have said this for you for 6 marks. Okay, because I want to help the student, at the same time I want to test your knowledge. So this problem is a beautiful problem. So try to practice this. So let's go for the next problem. Dear students, we are given a problem y equals on the root x into log x to base c. He is asking find dy by x, dy by dx at x equals to e. So the final answer, wherever you have x, substitute the value of x as e. That's all. Simple differentiation, but he has confused you with this. Don't get confused. At a final stage, when you finish the answer dy by dx, in that case, substitute the value of x as e. You got the answer. So some student, the moment they see this, how to go about it, they'll ignore the problem straight away and they'll not go ahead. So use your mind and try to solve this problem. It's a simple problem, we'll do it, right? Okay students, we'll take this problem, we'll differentiate this. So dy by dx equals to d by dx of under the root x plus log x to base c. This equals to half into under the root x plus log x to base c into d by dx of x into log x to base c. Okay, this is a solution. So here this part is over, need not have to worry about it, and here you have to use product rule because we have x into log x to base c. So that is nothing but 1 by x. Okay, let's see how to do it. So what I'll do, I'll take this 1 by 2 into x into log x to base c and take it outside. So use product rule, I keep as it is d by dx of, I keep log x to base c plus log x to base c into d by dx of x. Okay, just climbing the hill, no issues. Let's not worry. I know this is going little up, so don't worry. As you understand the problem, that's more than enough for me. So let us solve this. So what happens here? This equals to half I'll write this. Okay, one more step, no problem. Half into x into log xc. We'll solve this. That becomes x into d by dx of log x is nothing but 1 by x plus log xc to base c into 1. Okay. And I'll rub this. So this x cancels. So you are left with what? Half into, this is half into x into log x to base c. This is 1 plus log x to base c. This is our dy by dx. Now we have got the answer here. Beyond this we can't differentiate. So this is the thing. But what you have said, find dy by dx at x equals to e. Now what you do is, wherever you have got x, substitute the value of x as e. That's all. So what happens here? So he wants dy by dx. Take dy by dx. Dy by dx equals to, I'll write half as it is, within the brackets. This is 1 by e into log e to base c into 1 plus log e to base c. Okay, and close the square bracket. So I'll rub this. Now we'll simplify this. That is half 1 by, and this is log e into, I will write this separately, log e to base c one plus log e to base c. There is no need for this separation because you could have done easily. Only for your benefit, I am trying to take. I have taken one more step to make it easy for you. So what happens here? 1 by 2, 1 by root e. So here log e to base e is 1. So and root of 1 is 1. So that, so I will do is, so root of 1, since log e to base e equals to 1, since log e to base e equals to 1. So this has become 1 here into, okay, I will add this. Is 1 plus 1 because of this factor. Okay, I rub this. So on the left hand side we have dy by dx equals to half, I remove the bracket, this is 1 by e. So root of 1 by root, this is 1 only, 1 plus 1 is 2. So what happens here? This 2 and this 2 cancels, that is equals to dy by dx equals to, sorry, 1 by root e. So this becomes 1 by rotate. This is a required answer. So dear students, a very simple problem, but the examiner has made it look as if it is a difficult problem because of this factor. If you know this factor, the problem is gone. It's easy for you. Otherwise, you just ignore this from the examination and forget it, isn't it? So try to analyze the problem, because other than dy by dx, you have nothing else to do it, isn't it? So you should think for a while. Anyway, for the problem I have to get the answer for the solution for the problem. I have to differentiate this as it is. In the event if you fail to write the answer here, at least 1 mark let him cut, but at least you know differentiation, you can proceed ahead. So that's what I want you to let the problem be any sort of it, let it be a challenging factor. Don't care, don't worry about it. Try to be cool, differentiate it. You will get the answer, you can proceed. Because no problem is difficult. For every problem there is a solution, and you should know that you can solve it, because by now you should be well equipped to tackle any given problem to you. So dear students, that's the reason I'm taking a lot of pain to see that you improve on this and do more on these problems. Try to practice whatever problems I have given right from the beginning, and nobody can stop you in differentiation. That's my aim, and I know that you can do it, but to do that you have to practice. Without practice you cannot. So dear students, let me stop at this, and we'll think about, I think there's more than enough. We have done a lot of problems this time in the part 2, so there's more than enough for you. I want you to concentrate and practice it. Without practice you can't. Practice makes you perfect. Remember this, practice at home. Open out my YouTube channel, and one sincere request is, please follow my channel 1 and 2, where you get details of the list of formulae. So try to memorize those formulae. I have given all the formulas which is required for you for differentiation. If there is something important, as and when we are doing the problems, I will try to write beside the problem, but I hope I have covered all the problems which is required for differentiation. So please go to my channel, I think 1 or 2, this class number 1 or 2, and try to search for my channel, because I have given you continuous numbers, that is channel number or class number 1, class number 2, class number 3. Until today I have covered 21, including this will be 21 classes. So each class you will have different variety of problems, and you will be well equipped to counter any problem given to you. So follow my problems right from the basics, because I have made you strong right from basics. Without basics you cannot go ahead. So what I have learned from childhood, I am trying to impart it to you. So develop that attitude in you to fight and to answer any given problem. Don't leave any problem blank in the examination. So you can fight it out. So to do that you should be well equipped, and I know you can do it. So dear students, once again I request you, go to my channels, that's YouTube channels, take out all the problems one by one and try to practice, because if you're good in base, that's in the if your basics is good, it is sound, you can do your problems, otherwise you can't. Don't try to mug up and do it. Learn from the basics. That's why I've been telling you, learn maths from basics. I am there to teach you maths right from basics. That's what I mean, and I am following it. So students, let me stop at this for this class, part 2. Let's think about whether part 3 is required or not. We'll do it little later. So dear students, I stop here with the hope that you will like, share and subscribe to my channel. So I know for the hard work, for the efforts I am putting, if you are really sincere, if you think that yes, my sir is putting his best efforts to teach me, to teach us, so please try to like my video, share my video and subscribe to my channel, which is very important. That will inspire me, that will motivate me to do more problems for you, and I do a lot of problems for you. A lot to be covered in differentiation, because we have parametric functions, implicit functions, explicit functions, partial differentiation, successive differentiation and so on. So differentiation on the whole is a very big volume. I have to cover a lot for you. So I will do justice to you to see that you are good in differentiation, and if you are good in differentiation, you will be equally sound in integration too. So differentiation and integration is an important part and parcel of mathematics. You cannot ignore any of this too. If you have to be a good engineer, or a good scientist, differentiation and integration is must. But some students, what they do is they ignore it. They want to pass out. Some students join engineering, they ignore differentiation and integration. They focus only on infinite series, vector algebra, matrices, and so on, and try to clear out M1, M2, M3, M4 in engineering. That's not a practice. If you want mathematics, learn from base. So I'll help you. So dear students, let me stop here because I don't want to bore you. So students, please once again share my video, like my video, and subscribe to the channel. So stop right here. So good night students. Take care. God bless you. Thank you.